Alright, in the last video we talked about specific heat and energy, and I introduced this formula on where if we have a specific heat of a particular substance, like say water or anything, how we can calculate the amount of energy to increase or decrease its temperature. Alright, and we did just a simple calculation here with water, and this one we're going to get into solving for each one of these, whereas if I give you the energy and the mass and the change in temperature, what's the specific heat? Or vice versa, if I give you the specific heat and the energy and the change in temperature, what's the mass? And so on and so forth. So we're going to go ahead and work one of those problems now. Alright, so let's say I have a sample of lead here. Okay, let's say I've got 300 and, or no, let's just say I've got 35.6, keep it simple here, grams of lead, PB. And let's say I put 57 joules of energy into this sample of lead, and when I did that, it rose 12.5 degrees Celsius. So I had a change in temperature where it increased 12.5 degrees Celsius. What is using this information, what's the specific heat of my lead? Well, we can use the formula that we introduced last time, whereas heat, represented by Q, equals specific heat times mass times our change in temperature, delta T for change in temperature. Well, we're given the joules, right? That's 57 here. And we're given the change in temperature right there, and we're given the mass. So we want to solve for specific heat. So all we're going to do is divide over to solve for specific heat. So we're going to divide both sides of this equation by mass and the delta T. Mass, that's kind of a janky M. There we go, let me rewrite that. And the delta T. These are going to cancel out on this side, and we're going to be left with specific heat, or energy over mass times delta T equals our specific heat. Pardon me. Alright, great. So now we have the hard part out of the way with, right? Most students struggle with figuring out how the heck do I solve for this problem. You know, well, it's simple if you just do the cross multiply and divide over method. You just divide both these sides and you get your formula, plug in your values, and solve. So the hard part's over with. Now I'm just going to plug in my Q, which is my heat, is 57 joules, right, over my mass, which is 35.6 grams, and my change in temperature times 12.5. Really, I shouldn't have these right here. Or no, I guess it doesn't matter. Alright, times 12.5 degrees Celsius. Alright, so when I do this, nothing's going to cancel out. Whereas before, in our last problem, let me scroll back up here. Where was I at? Alright, whereas in our last problem here, grams canceled out and Celsius canceled out. We were left with joules. Right, we were left with joules. In this problem, nothing's going to cancel out, right? Because there's no grams up top here, or Celsius up top here, or anywhere else in the equation. So my units are going to be joules over grams times degrees Celsius, which makes sense because that's the units for specific heat, and that's what we're solving for. So let's just grab our calculator. Let me put it about right there, I think. Should be able to see about right there. Alright, so we've got 57 divided by 35.6 divided by 12.5. Alright, and that's going to equal 0.128. 0.128. And I'd stop there because I have 3 significant figures overall in my problem here. Got 3 there, 3 there, 3 there. So 0.128 would be my final answer. And that's joules per grams degrees per degree Celsius. You may have noticed something unusual that I did with my calculator, where I just did 57 divided by 35.6. Then I just turned around and divided that by 12.5. You can take and do 35 times 12.5, rewrite that down here, and then divide 57 by whatever that is. But it ends up being the same if you just take 57 divided by 35.6, then divided by 12.5. I have had people ask me about that in the past, so if you never learned that in math or algebra, it's just a time-saving trick that you can do. Anyway, that's how you solve for specific heat. Let's kind of throw a curveball in there with specific heat, right? Because you're probably going to do a lot of problems where you end up solving for specific heat. Let's say, let me scroll this down a little bit more here. Let's say we're dealing with water again, right? And the specific heat of water is 4.184 joules per grams per degree Celsius, right? Well, let's say they give us in our problem, they say the specific heat of water is that, and they say we've got 300 Kelvin, and we've got 5 kilograms, and that's our specific heat. We want to know how many. Let's just get real crazy and say we want to know how many kilojoules that is. So how many kilojoules are in all this, right? Well, don't let this intimidate you. Just because your specific heat is in joules per grams degrees Celsius doesn't mean that you can't do the problem, right? You can take and convert specific heat into kilojoules per kilograms per Kelvin, or you can just convert this from Kelvin to degrees Celsius, kilograms to grams, and then that'll give you your final answer in joules. Convert that to kilojoules. At this stage of the game, that's probably how I would do it if I were you, just because this might be opening up a whole other can of worms to make silly mistakes and get the wrong answer. So I'd probably stick to doing it this way, right? So we know if we're going to go from Kelvin to degrees Celsius, that we're just going to subtract 273. And I know that if I have 5 kilograms, that for every 1 kilogram, there's 1,000 grams in there. So that's really going to be 5,000 grams. Right, 5,000 grams there. And I just wrote that out so you can see what I'm doing. Go ahead and erase that though so I can clear up some space. Alright, so I've got 5,000 grams there, and if I've got 300 minus 273, so that's 27 degrees Celsius. Hope you can see that, 27 degrees Celsius. Alright, so now it's basically just plug and chug, right? We have our mass in grams, which matches that. We have our temperature change in degrees Celsius, which matches that. And our final answer is going to come out in joules, but we can change that once we get it. So we know that energy, or joules, equals specific heat, which is 4.184. Looks like a Y, but it's really supposed to be a 4. Rewrite that there. Joules per grams degrees Celsius times 5,000 grams times 27 degrees Celsius. Alright, grab your calculator. 4.184 times 5,000 times 27 equals 564,840. 564,840 joules. We need to put that into kilojoules. So for every 1 kilojoule, we have 1,000 joules. That's going to be 564.840 kilojoules. We've got 4, 1, and you really don't count that. So you would probably just round this up to 600 kilojoules is what you would end up doing. Let me scroll down in case you can't see that. So you would probably say 600 kilojoules on this answer for one significant figure. Okay, good deal. I hope that helps. Thanks for watching. In the next video, I'm going to talk about how to solve for the delta t, and that one's probably the trickiest equation or quality in the equation to solve for. So anyway, thanks for watching. Hope that helped.